Hello, my amazing Algebra 1 students. This is Mrs. A, and I love math. Today, we're talking about Lesson 13, and the first part of it is multiple symbols of inclusion. What do we do when our symbols of inclusion are stacked upon each other? Well, the rule for our symbols of inclusion, which are parentheses, brackets, braces, absolute value, those symbols of inclusion are going to be done left to right, but also inside out. So we're going to look at this big symbol of inclusion. We're going to say, oh, but we've got one inside of that. So we're going to go straight to the innermost symbol of inclusion, which is this parenthesis right here. So the very first thing we're going to do is -2 minus 4 is -6. So now we're going to break out this symbol of inclusion and say -6 minus 3. And -6 minus 3 is going to be a -9. So the whole thing here is -9. And so now we're going to bring the rest of it. Notice that this whole thing is multiplied by the -3. And then afterwards, we're going to subtract the 2. So it's fine if you do this, if you break down, you don't have to write the whole thing every time, but you do need to be orderly in the way that you do it. So notice that I break out the 1, and then I wrote that and that together in the big bracket here, and then I figured out that that was -9, and then I brought all of the rest of the problem back together. So I'm still not done, right? But multiplication takes priority over subtraction here. So -3 times -9 is +27, and +27 take away 2 is going to be 25, and that is the correct answer. So we're going to be working problems like that one here. And this one is a doozy, isn't it? Look at all of those symbols of inclusion. But remember, we're going to go to the innermost. And all of our symbols of inclusion should have matching start and finishings. So see the brace here and the brace over here. And then right here, I have a bracket. And then I don't see another bracket until here. So that's the closing bracket. So inside of that, I have to start working. And inside of that, I will work left to right, starting with my first symbol of inclusion. So here is the one we're going to do first. -3 minus 2. -3 minus 2 is -5. So this one is going to be -5. And then we have another symbol of inclusion right here, which is -7 plus 4, which is a -3. But notice that both of those are in their own parentheses. So now let's take our big brace and rewrite it. So we're going to just include this bracket here because we're still working within the bracket. So starting with the bracket, that means I'm ignoring the 2, I'm ignoring the brace. I'm going to bring those along later, but right now we're just working on the big bracket, okay? So we put the big bracket, and then this one was a -5, and I'm going to put its parenthesis with it because I just evaluated what was inside. I'm going to put another parenthesis touching it, because that's what I see here, and then the -5, and that will include, that's what's included in the big bracket, okay? So now we're still simplifying in here before we bring the rest of this on. So 15 minus 5 is going to be 10. So inside the bracket is 10. Now I'm going to bring everything else out here. So to the left of the bracket was a 2, and then we had the brace, and then we had the 4, and then on the other side of the bracket was the brace minus the 2. Whew. A lot of work, okay? But now we're looking inside this, and it's easier to see because there's not as much in there. 2 times 10 is going to be 20, and then we come out here, we have 4 times 20 is 80, and lastly, we take away the 2. So 80 take away 2 is 78. And these are problems right out of your book. Okay, but that's how you do them. Now notice that I do them a little bit differently than your book does them. And the reason I do them just a little bit differently is because I know myself. The more I write a problem, the more I tend to make an error. So what I do is I give myself permission, and I give my students permission too, to come in and show me what they're working on, and then to work on that, and then bring the rest of the problem down. Both ways are fine, okay, because what you're doing is you're defining this part and then you're bringing it all back together. As your problems get longer and longer and longer, and they will, sometimes it's easier to focus in on a small part of the problem and then bring the whole problem back along again. So you'll see that in your book, they do it just a little bit differently, and that's fine. They're correct. But I'm just focusing in on a small part and then coming back, because I know the more I copy a problem, the more I tend to make an error. So I copy a problem as little as I can just because of that proneness to errors that I have. So you do the way that's going to work best for you. The ultimate thing is that we bring the problem all back to the end, and the answer is 78, which you should get either way you do it. Okay, the biggest thing is you should always show work. Whether you show your work step by step, copying the whole problem over and over again, or whether you take a little segment out and work that part and then bring it all back, you should show your work. So let's go do another one. Okay, so this is the last example in this section, and then we're going to move on to something else. So we have a -3 in front of this brace, and then we have a bracket, 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 and then on the bottom we have more. Okay, so what I'm going to do is I'm going to look specifically right here. So I've got -2 minus 3 is my innermost on the left. So remember, we're always going to move left to right, but if they are stacked to where we have parentheses inside of parentheses, then we're going to do them in to out. But notice that this one is on the left and this one is on the right, so we can do them left to right. -2 minus 3 is a -5. So I'm just going to put a -5 right here, and then we have the -2. So now when I look out, okay, then I say, okay, I've got this bracket here, which is a -5, and I'm multiplying it by this bracket here, which is a -2. Some of these problems can be so much and so busy that some students that might struggle with dyslexia or visual perception could have a real hard time. So when you do, you need to maybe get a different color so that you can delineate where your endings and startings are. That might help you. So we have a -5 times a -2. We know that -5 times a -2 is 10. So let's take that 10, and starting there, we're going to put that, have we not just done that whole big brace there? And we found out that it was a +10. Okay, so now let's bring this in. So -3 comes in front as multiplied by, and then on the bottom we've got -3 times 4 minus 2. And the 4 minus 2 is going to be a 2. Now let me look at that right there. How would you work that problem? Would you multiply it out and get -30 divided by -6, which it is. It is -30 divided by -6. That's true, but it's not simplified, is it? Can you see a common factor in the numerator and the denominator? Don't they both have a -3? Would it be quicker, instead of writing -30 over -6, to cancel those two -3's and get 10 over 2? And 10 over 2, we know, is 5. So the final answer for that example is 5. Okay, and 5 is much easier to look at than this whole thing. Do you see how we broke it down step by step? Okay, so Teachers, because many times these are used by people that are teaching at home. If you have a child that is struggling with just the visualization of what's going on here, using colored pencils can be excellent to match up the grouping symbols. And also, it may be good for your child to just be able to evaluate and write above instead of try to rewrite the whole thing, because it can be difficult if there's dyslexia or dysgraphia or any of those things that are plaguing your child, to still get the concepts without having to copy over all of these difficult symbols every time. You might find that to be beneficial. So -5 times -2 is the gist of it, isn't it? And then we get the 10 and we bring the rest of it around. If you do use a shortcut method, you must remember to bring it all back together at the end. Okay, and we're going to do a couple of practices at the end, but first of all, we're going to go ahead and do part B, which is more on order of operations. Okay, now we're going to talk more on order of operations. And remember, when we are talking about order of operations, we're going to talk about PEMDAS, or please excuse my dear Aunt Sally. Now, we just talked about our parentheses, brackets, braces, our symbols of inclusion. Those always come first when we're doing order of operations. And we have not talked about exponents and roots yet. We will do that later. So we're going to skip over that one for right now. But we have talked about multiplication and division being on the same level of order of operations, which means we're going to do them as we see them as we go left to right, and addition and subtraction are on the same level as well. So if you were talking about military ranks, parentheses would be at the highest rank, and then exponents would be at the next highest rank, and then multiplication and division are at the same rank. We're going to do them as we see them left to right, and addition and subtraction are at the same rank. So let's look at this problem right here, and we're going to talk about how we would do this according to our order of operations. When we have our division sign in the middle like this, we're going to do everything on the numerator and then everything on the denominator, and then we're going to simplify. So we're really going to treat it as two separate parts to the problem. So on this numerator, we're going to look and see we have a multiplication, which is a higher rank than the addition. So 12 plus the 2 gives me 14. And then -7 plus 5 gives me the -2. So we'll erase this right here so we have some room. Okay, so this is going to be -2. And 14 divided by -2 is -7. Okay, now the one that we have down on the bottom has a division also, but the division's not a big division sign in the middle. The division is right here in the middle of the problem, and it's a 14 divided by 2. Since it is a division, and over here is a multiplication, and they are the same rank, we will do them as we see them, but we skip over the addition because the addition is a lower rank. We will come back and do the addition later. So our answer, our intermediate step for our answer, is going to be 4 plus 14 divided by 2 is 7. So we will have 4 plus 7, and then -3 times 6 is a -18, so we'll have a minus 18, which is the same thing as a plus a minus 18. So now we're at the point where everything is the same level, the same rank in our order of operations. So 4 plus 7 is 11. Take away 18 is -7. Okay, so that is another way to Another rule for our order of operations is that multiplication and division are on the same level. So we're going to be doing a lot of practicing with order of operations because it is so very important. So here is that board so that you could see those two problems worked for you. This problem is an interesting one. Notice that we skip over the positive because it's a lower rank, but we have 3 times 6 divided by 2. So we have 3 things right in a row, and we will do them left to right. And then over here, we have another multiplication that we will do after we do this one. Our rule is to always move left to right with our multiplication and division. Since they are at the same rank, we will just hit them as we see them. So the 6 plus is going to stay there, and then we're going to say 3 times 6 is 18, and 18 divided by 2 is 9. And then we have a minus 6 times a 2, and a negative 6 times a 2 would be a negative 12. Now, your book doesn't jump all the way down there. Your book does it in a few more steps, but essentially they write 18 divided by 12, and I went straight to 19. So you can do it the way your book says it, or you can say 18 divided by 12 by 2 is 9, because you're doing all of those at the same time in order. And then we have 6 plus 9 is 15, then 15 take away the 12 is 3. And that would be our final answer on that one. So look at that board real carefully, and we're going to come back with more examples. Okay, this one's kind of fun. Okay, we're doing products of signed numbers, and we have 2, negative 2, negative a negative 2. Now they're telling you to read it opposite of, which is fine. Here we have a 2, and then we have the opposite of a 2, which is a negative 2. Okay, and then over here we have the opposite of an opposite of 2, which basically flips the sign back to a positive 2. And then we have the opposite of the opposite of the opposite of 2, and each one of those negatives flips the sign over again. So the opposite of a negative 2 is positive 2, and then the opposite of that is a negative 2 again. And then down here we have the opposite of the opposite of the opposite of the opposite of 2. Okay, so negative 2, and the opposite of that is positive 2, and then the opposite of that is negative 2 again, and then the opposite of that is positive 2 again. How did I get a 3 there? I'm not sure. It's a 2. Negative 2. All right, so basically what they're wanting to see is that when we have 1 or 3 negative signs stacked, we're going to get a negative. But when we have 2 or 4 negative signs stacked, we would get a positive 2. So we're coming up with a pattern, aren't we? So here we have negative 2 times negative 2, which is going to be positive 4. And then we have a negative 2 times a negative 2 times a negative 2, which, remember, 2 of these made up a positive 4. So a negative 2 times a positive 4 is going to make the answer negative again. It's going to be a negative 8. And then we had 4 of them multiplied together. So we have a negative 2 times a negative 2 times a negative 2 times a negative 2. That's a lot of negatives. Don't be so negative. And that's going to give us a positive 16. So our rule is that if we have a even number, like 2, 4, 6, or 8, if we have an even number of negatives multiplied together, we will get a positive. If we have an odd number, like 3 negatives multiplied together here, we got a negative 8. If we have an odd number of negatives multiplied together, we will get a negative number. And that's how easy it is. So, even number of negatives is positive, and an odd number of negatives is negative. Okay, so now we're working on just some problems. Now, I changed this one a little bit because they had some pretty big numbers, and what I'm trying to get you to see is the signs. So 4 times a negative 2 times a negative 4 times a negative 2 times a 1. So if we're going to follow the sign rule that we just learned, they're all multiplied together. And we have 3 negative signs. So 3 negative signs should wind up being a negative, shouldn't it? Okay, because we just had the rule that if we had an odd number of negative signs, it would wind up negative. So let's check. Okay, so 4 times a negative 2 would be a negative 8. And then the negative 8 times a negative 4 would be a positive 32. And then the positive 32 times the negative 2 would be a negative 64. And then, of course, times the 1 stays the negative 64. So we did get a negative sign as we expected. So here we come back with another example. This is a fun example because we're going to not have to do the multiplication. We're just going to decide what sign it's going to have. So here, this is all multiplied together. And we have 1, 2 negative signs, and the rest are positive signs. So since 2 is an even number, our final result will be positive. Okay, so here we've got positive, positive, positive. And they're all multiplied together, so our final result will be positive. We didn't have any negative signs in there at all. Here we have a negative, negative, positive, positive, negative. So altogether we have 3 negative signs, and 3 is odd, so we're going to wind up with a negative result. Negative, 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 negative. There are 5 negative numbers. 5 is an odd number, so we will end up with a negative result. This last one does not follow the rules because it is not a product all the way across. So we will do it in 2 steps. We'll look at these, which are a product, and we're going to end up getting a negative number here. This last problem, this first part is a sum, and it has a negative times a negative times a negative that we're going, well, it's a product, but we're going to, this is a sum right here. So we've got a negative times a negative times a negative, 3 of them, so that's an odd number of negatives. So that's going to be a negative number. And then over here, we've got 2 times a negative 3, which is a negative number. And so a negative plus a negative is a negative. So we're going to get a negative there. So that was a lot of problems in one. Okay, now we're on practice A. And remember, we have to put it all together now. We have a symbol of inclusion here. We have braces that go all the way across. And then inside the braces, we have some brackets. And then inside the brackets, we have some parentheses. So we're going to go to the innermost here. We've got 2 parentheses right here that we're going to deal with first. And so we have a negative 4 minus 3, which is the same thing as a negative 4 plus a negative 3. So that's going to be a negative 7. So this one right here is going to become a negative 7. Then we're going to come over here to this one. So we'll go ahead and put this one in parentheses, just like it is. Then negative 8 minus 2 is a negative 10 minus a 4. And then we're going to go ahead and put this big bracket. And then we'll put the 2 and the brace and the 3. So I just went ahead and copied all of it down. So now we're going to go back in here to the middle of this bracket, and we're negative 7 times negative 10 is a positive 70. And positive 70 take away 4 is a 66. So there's the bracket, and then there's the 2, and then there's the brace, and then there's the 3. Okay, so 2 times 66 is 132. So then we have 3 times 132. That's going to be 3, no, let's do that. We're going to have to do that on a separate little place here. But go ahead and look at that, and then we'll multiply that last little part together. But it will be positive, won't it? The last bit will be positive. 3 times, well, it will be 396. We can do that in our head. 396 is our final answer. Okay, that was a big one, wasn't it? Lots of stuff to do in that one. Okay, next practice. Okay, on this one, we're going to do the numerator, then the denominator, and then put them together. So we have -4 minus 1 is a -5. And then -5 times a 3 is going to be a -15. So let's write that out. So we're going to have negative, we'll just put a big one there, -3. And then we have this right here, bracket. -5 times 3 is 15. Negative -5 brace over 2 times 4 minus 7 is a -3. Oh, this is looking easier now. So -15 minus 5 is a -20. -20 times a -3 is a +60 divided by a -6. 2 times a -3 is a -6. And 60 divided by a -6 is a -10. So the answer for that one should be a -10. Okay, these are the last practices here. So we have a negative, 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 negative. 4 negatives is an even number. So we're going to wind up with a positive result. And that's going to be 2 times 2 is 4. 4 times 3 is 12. 12 times 3 is 36. Okay, so down here, we have a negative, 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 negative. 4 negatives. Even number of negatives. Therefore, we're going to get a +2. And the last little one I did not copy down because it was a long string of numbers. They were all multiplied together and 7 of them were negatives. They just wanted us to tell the sign. If we have an odd number of negatives, our result will be negative. And that is the end of Chapter 13. And this is Mrs. A, and may God bless your day.